when there is an algebraic expression in the denominator of each fraction, so an algebraic expression here in the bottom of each fraction, we can obtain a common denominator by writing the product of the denominators. So in other words, we have an algebraic expression in the denominator of each fraction. Our common denominator for each fraction is going to be, let's multiply these together, x plus 3, x plus 2. So that is our common denominator. Now, what I say to myself is, what is now here on the bottom of this fraction that was not here? And the answer is x plus 2. So we've put an x plus 2 on the bottom. That's okay. Let's put an x plus 2 on the top. So whatever we've done to the bottom, put an x plus 2, we need to do to the top. Let's look here. What is on the bottom here that was not here? And the example, it's x plus 3. So what we need to do is, on the top here, we need to put the same thing. We need to put an x plus 3. So whatever you've put on the bottom, you also put on the top. So we've got a common denominator, and now what we do is, using our knowledge of binomial products, we multiply out the top. We multiply out the brackets. So we go x times x is x squared, x times 2 is 2x, 1 times x is 1x, and 1 times 2 is 2. That is all over our common denominator. Similarly for the next fraction, all over our common denominator, and let's multiply out these brackets. 2x times x is 2x squared, 2x times 3 is 6x. Negative 1 times x is negative 1x, negative 1 times 3 is negative 3. We have common denominator, we put it over the one common denominator, and now we can add these fractions together. So let's look at our like terms. We have an x squared and a 2x squared. So when we add those together, that's 3x squared. We have 2x, we have 2x plus 1x, that's 3x, plus 6 more x, that's 9x, subtract 1x, that is 8x. And then we have 2 subtract 3 is negative 1. So what we have done is, when there is an algebraic expression in the denominator of each fraction, we can obtain a common denominator by writing the product of the denominators, which is what we've done here. Then, whatever we add to the bottom, we have to add to the top, as indicated in yellow. Our next example. We have to work out what the common denominator is. This one here has x minus 3, and this one here, remember, x minus 3 squared is the same as saying x minus 3, x minus 3. So our common denominator is x minus 3, x minus 3. We put that under both fractions. Then we say, what is on the bottom here that was not there? Well, there's an extra x minus 3. That's okay, as long as on the top we also now put an extra x minus 3. With the next one, what is on the bottom here that was not there? Nothing. It's the same. So we haven't done anything to the bottom, so we don't do anything to the top. So now we have our common denominator. Oh, sorry, I've jumped one step ahead. So now with this one, I will multiply my brackets out, so my binomial products, x times x is x squared, x times minus 3 is minus 3x, sorry, subtract 2 times x is 2x, and 2 times minus 3 minus 6, and I don't have to do anything over here. Now, put them all over the one common denominator, and let's look at our like terms. X squared, there's only one x squared mentioned. There's no x squared mentioned anywhere else. So there it is. Let's look here. We've got here's our terms with x, and here's our term that has no pronumeral. So if we combine our like terms, the green gives us x squared, the aqua gives us 0x, which cancels out, and then we have -6, -1, in the pink is -7. That is how we do that one.